Hello everyone, myself Dr. Santyavi Kundu. I welcome you all to this lecture of soft computing techniques. This is the fifth lecture of module 10. So in this module, we have learned reduct and core, distributive matrix and distributive functions. Today we will solve few more questions based on these concepts. So first question is that we have one decision table. Here there are 6 patients P1, P2, P3, P4, P5, P6. So these are the objects. Attributes are headache, muscle pain, temperature and flu. So flu is the decision attributes. So this attribute is flu. So for P1, headache is no, muscle pain is yes, temperature is high, flu is yes. For P2, headache is yes, muscle pain is no, temperature is high, flu is yes. For P3, headache is yes, muscle pain is yes, temperature very high, flu yes. For P4, headache is no, muscle pain is yes, temperature is normal, flu is no. For P5, headache is yes, muscle pain is no, temperature is high, flu is no. For P6, headache is no, muscle pain is yes, temperature is very high and flu is yes. So this will be the 6 cross 6 matrix. It is P1, P2, P3, P4, P5, P6. So in the column we also have P1, P2, P3, P4, P5, P6, but we can eliminate the last column. So delete last column and delete first row. So we have the start with P2, P3, P4, P5, P6, here P1, P2, P3, P4, and this will be the lower diagonal matrix as it is symmetric. So compare with P2 and P1, see the decision is same. Yes, so there will be lambda. Now compare with P3 with P1, decision is same, so it is lambda. For P3 this with P2, decision is same, so here also lambda. Now for P4 with P1, decision is not same. So here P4, so no headache will not there, muscle pain is not there, only temperature. Here it is the normal and here it is high, so there will be T. Now P4 with P2, so as you have seen that decision is not same, so here this headache is different, so headache, then here we can write here the P4 and that muscle pain also different, temperature also different, so we write HMT. So here T for temperature, T for temperature and H for headache and M for muscle pain. Now compare it P4 and P3, so here also this is not same, so that P4 with P3, so headache is different, muscle pain is same, so H and T. Now P5 with P1, so P5 with P1, so this is not same, so we need to write the attribute which are values are different, so our values are temperature is same, so headache and muscle pains are different. Now the interesting case with P5 and P2. So P5 and P2, there is the decision is the not same, so that is the so then we need to write something. But see here all attributes are same. Headache is same, muscle pain is same, and also temperature is same. So there is it. It is the null set. Now P5 with P3, so it is the not same decision, so we need to write something. So here headache is same, it is a different, muscle pain and temperature is different, so here write M comma T, and here this is same P4 and P5, so we write a lambda. Similarly P6 with P1, this is same, lambda, decision is same, lambda, decision is same, lambda. For it is P3, so all are lambda. Now P6 with P4, headache is same, muscle pain same, only temperature is different. So write here T. Now here everything is different, so write here HMT. So that is the basically you can write that this is the discernibility matrix. Now the discernibility function, so here it is T into H plus M plus T into H plus T like that. So discernibility function is T into H plus M plus T into H plus T into H plus M into M plus T into H plus MT. So we need to do some Boolean algebra. So here we'll get T dot H plus M, so that is HT and MT. So we can say these are the reduct. So reduct O1 is H and T, and reduct 2 is M and T. So core, you know, the core is the intersection of all reducts. So here core is the HT intersection MT. So core is T. So T is the core, I mean temperature is the core here. So we need to learn some laws of Boolean algebra. So some laws, no need to write all the laws because we will not use the complement. So as you know, the Boolean algebra is basically the 6 tuples where the B is the set, plus you can write it for union, dot means for intersections, 0 means for the null set, 1 means for the universal set, and this is complement. So these 6 tuples is known as Boolean algebra. So some laws are there, commutative law. So x plus y equal to y plus x is just like a set theory. You can write it. Some set is x, capital X union y is equal to y union x. Similarly, x dot y means x in intersection y equal to y intersection x. Similarly, this is the associative law. X plus y plus z equal to x plus y plus z. You replace the plus by dots, will get x dot y dot z equal to x dot y dot z. Some distributive law, x plus y plus z is x dot y plus x plus z. It is the same thing like that. This law, A intersection B union C, you know that is A intersection B union A intersection C. Similarly here also, that A union B intersection C is equal to A union B intersection A union C. So this is the some laws of Boolean algebra. Now identity law, x plus x equal to x, x dot x equal to x. Some rule is there, so that is x plus x dot y is x, x dot x plus y is x. So this is also one law. So now try to understand a few more examples for discernibility matrix and discernibility functions. So here these are the some objects u1, u2, u3, u4, u5, u6, u7, attributes a, b, c, d, and this E is the decision attributes. So this is decision attribute. So in the row we will get this u1, u2, u3, u4, u5, u6, u7, and column also will get something like u1, u2, u3, u4, u5, u6, u7, etc. So we can eliminate the last column and first row, so it will now become 6 cross 6, not 7 plus 7 matrix. So just check the matrix first. So this is the table we write here. So here so in the we can eliminate the last column, so that is u7, eliminate first row, that is u1. Now this is same from, if you compare with u2 and u1, this is same, so there is lambda. Now compare with u3 and u1, this is not same, so A is same, B different, C different, D different. So here is B, C, D. Similarly compare with u3 and u2, this is not same, but A is same and B, C are different, so it is B comma C. Similarly, compare with U4 and U1. This is not same, so compare A is same, B is different, and only B is different, so it is B. Similarly, if you compare with U4 and U2, B and D different. Compare U4 and U3, C and D are different. Compare U5 with U1. U5, this is not same, so I think everything is different. So here it is A, comma B, comma C, comma D. For U5 with U2, A, comma B, comma C. Now U5 with U3, this is same, so lambda. Now U5 with U4, this is different, but all attributes are also different, so it is A, comma B, comma C, comma D. Similarly for U6 and U1, all are different. At D is same. Here this is same. U6 and U3. Decision is same. So it is lambda. Similarly U6 and U5, this is same. So this is lambda. U7 and U1, this is same, lambda lambda. So now it is U7 and U3. Decision is not same, so I think all attributes are different, so here A, comma B, comma C, like that. So here we can write the discernibility functions. Discernibility functions. Here is B plus C plus D dot B plus C dot B dot B plus D dot C plus D. Continue dot. For here A plus B plus C plus D. Here A plus B plus C. Here it is A plus B plus C plus D. Here also A plus B plus C plus D. A plus B plus C dot A plus B plus C plus D dot A plus B plus C plus D dot A plus B dot C plus D dot C plus D. So after solving it, simplifying, you will get it B dot C plus B dot D. So the redact is B comma C, redact 2 is B comma D, and core is the intersection of these two, that is B. So you complete these things. Now this is the another example. So here some attributes are degree, experience, communication skill, recommendation, and this is the decision. So objects are x1, x2, x3, x4, x5, x6, x7, x8. So degree is something like 1, experience M, communication skill is Z, recommendation is E, this is accept. For x2, degree is 2, experience is H, communication skills is G, recommendation is N, this is accept. For x3, degree is 2, experience is H, communication skills is Z, recommendation is E, this is accept. For x5, you can write it 1 L G N, reject. For s6, 3 L G G, and reject. For x7, 2 M G N, reject. For x8, 3 L B E, reject. So we need to find the discernibility matrix, so that we know if we eliminate first row and first last column, so we'll get it first row, so we'll get up to x2 to x8 will be there, and here we'll get up to x1 to x7. So we write here x1, x2, x3, x4, x5, x6, x7. So that is the discernibility matrix. So with x1, with x2 and x1, this is same, no need to write lambda. For x2, for x3 to x1 lambda, x3 lambda. For x4, here also will that for x4, so that is the accept, so here we will get all three are lambda. Now x5 is reject. Here this is not same. Now check what are the different. So x5 with that D is same, E is different, Communication skill is same, so recommendation is not same, so this is ER. So here we write that D for degree, degree is D. Experience, we write that E. Communication skill, we write it as the skill, we are writing as like it is C. Recommendations, recommendations is like R, so smaller. So here that is ER, so here extend D and E, so DER. So in this way you can write the discernibility matrix and also write this discernibility functions and find the redact and core. So now try to understand one more question. So that is question is that compute discernibility matrix and redact from the given hiring decision table. So whenever we are going to find redact, we need to find the discernibility functions. Discernibility functions. So this is decision table. There are 9 objects: U1, U2, U3, U4, U5, U6, U7, U8, U9. Qualifications MBA. So you can write it Q, and English like E, and recommendation is R. So U1 qualification MBA, experience medium, English is yes, recommendation excellent, decision is accept. For U2 qualification is MSc, experience is high, English is yes, recommendation neutral, decision reject. U3 is MSc, experience is high, English is yes, then recommendation is excellent, decision is accept. For U4 qualification is MBA, experience is high, English is no, recommendation is good, decision is accept. For U5 MBA low, yes, neutral, reject. For U6 MCA low, yes, good, reject. For U7 qualification MSc, experience medium, English yes, recommendation is neutral, decision is reject. Similarly for U8 MCA high, no, excellent, accept. For U9 MBA high, yes, good, and accept. So these are the one decision table is given. We need to find the discernibility matrix and that. So discernibility matrix, you know that the row will be U2, U3, U4, U5, U6, U7, U8, U9. Column will be U1, U2, U3 up to U8. Now we are going to calculate the discernibility matrix. As we assume that qualification as Q, experience as X, English as E, and recommendation as R. So you know there are 9 objects. So in the row you will get U2, U3, U4, U5, U6, U7, U8, U9, and in the column you will get U1, U2, U3, U4, U5, U6, U7, U8. So we delete the row for U1 and column for U9. So this is the 9 objects, so it becomes 8 by 8 cross matrix. Now we need to write the entries. So for that we need to compare it. So now compare with U2 and U1. So compare with U2 and U1. So here see that qualification is different and experience is different, recommendation is different. First of all check the decision, so this is different. So now compare it. So Q, E and R. So here you will get Q for experience. So experience is X, so Q X R. Now compare with U3 to U1. So compare U3 to U1. So decision is same, so there should be lambda. Now compare with U3 to U2. So qualification is same, experience is same, and you can say that English is also same. So now there is different for U3 and U2. So there should be only the difference in is recommendation, so there should be R. Similarly for check U4 and U1. So U4 and U1, these are the Same thing, so there is no need to write. So lambda. Now u4 with u2, so qualification is not same. Then experience is same, English is not same, recommendation is not same. So here we need to write it QER. So experience same, so X is not there. So and U4 to U3. So if you check U4 to U3, so decision is same. So this should be the lambda. Similarly for U5 and U1, so experience and recommendation will be the different. So check these things. So experience and recommendations are different, rest all are same, and this also different. So now u4 to u1. Now check the next one, which is that u5 to u2. So decision is same, so that should be lambda. So check it, u5 to u2. So u5 to u2 decision is same, so lambda. Now u5 to u3 decision is not same. Now this qualification is different, experience is different, English is same, recommendation is different. So there you will get qxr. Similarly there you will get x here. So in this way you can find the entries of discernibility matrix. Now with the help of the previous all concepts, here you try to find discernibility matrix, find discernibility functions, and reduct and core. So conclusion, I hope in this class you have understood what is the discernibility matrix, you have understood discernibility functions, you have understood the reduct, you have understood the core. So question is that consider any decision table, consider any decision table, find all these things, that is find discernibility matrix, discernibility functions, reduct and core. So these are the references of today's class. Thank you.